Yes, that was the most expensive loaf of bread I've bought in my entire existence. This is before the time of business intelligence, where we're now integrating a lot of those things. Technology, I mean, anything is possible. Lightning speed applications. We heard from somebody that talked this morning about high-performance computing and whatnot. But the business intelligence that companies like Microsoft and Tableau Software and IBM and Smarter Planet and those kinds of things, a lot of other companies are focusing on, really kind of harness technology to the user experience and the customer satisfaction. So it's good to see some progress going on there. That's not the topic for this afternoon. For my talk, I'm going to be talking with you about some accessibility obstacles that I've identified based on a case study. Now, this is a case study of one. I did anecdotally, after performing this, look across a number of other web applications just to kind of do a sanity check. Am I seeing these same kinds of problems typically across web applications? And I feel kind of, from that kind of anecdotal, more landscape view, that these do apply, so that it's worth talking about today and hoping to help other people avoid them. So just a really quick recap, I think probably everybody watching this is familiar with accessibility. It is an aspect of design, but it goes a lot deeper than that. It's a code architecture standard, and because it really crosses the design and the underlying code aspect, the teamwork between user experience professionals and actual developers is really key. So that partnership, which is a very tight partnership, and you'll see some aspects of that through what I talk about in a few minutes, is really important. So our objective is to enable all people to use our software. Financial institutions, universities, commercial organizations, software producers are all focused on this. We want to enfranchise every citizen. We don't want to see a digital divide get wider. So focusing on disabilities, it could be visual. We heard from Jenny a little bit earlier about oral audio capabilities, but could be physical mobility, where somebody maybe can only use a pointing stick or cannot use a mouse, but could hit a key. So keyboard-only access. So we're going to look today at just a baseline evaluation that I conducted over the last year. So I worked for a year at the University of Washington in a position that was funded by a grant from the Koale Foundation, which is a nonprofit organization that helps a number of universities get together and collaborate on building software for universities by universities. Now, this is the type of software that each university would probably have to build in-house, custom, by themselves, or contract out to an agency to build for them. So it's not something that we would typically see coming off the shelf. But there is a Koale financial system, and there's a research application, and there's a student application, and the University of Washington has actually been one of the earliest to use the middleware, which is what I worked on, the user interface framework, which is part of the middleware, RICE, it's called RICE middleware, in the MyPlan. So it's helping students do academic planning, and their 4-year or just their next semester. But we looked at this middleware and the toolkit that we had and we were providing. We looked at what we had already in 2011 and did a baseline evaluation to see where we were, to find out what were the common mistakes we were making, and then actually fix them. So I'm going to talk a little bit about some of these things. So we know that web applications, unlike the internet that started initially, which was just information and you could browse through it and read, much more passive, we're now seeing applications move from the desktop to the web. So you can think about full interactivity. These are rich internet applications. So these are the code architecture standards. There's a lot of information available to you. I actually have links in the slide deck, and this deck will be made available, I think, on the web after the talk, so people can see it. There's a lot of information in the appendix that we won't have time to get to in 10 minutes, but it'll be there for you to look at afterwards. So we're going to look at things. This is just a sketch, non-styled, but just to show that actually in a web app, you're going to see things that are dynamic user interaction. You can see data entry fields. You can see select controls, date pickers. You'll have actions like add, save, delete, any other custom action. You can have automatic totaling. So imagine that this is just one section of a form on a page. And you can even see that this is a collapsible and expandable section. So what did we do? We, after evaluating, the team got together and actually we designed and architected potential solutions, and some of those are already in the product that has come out this fall. The objective, of course, is to build accessibility into the user interface framework so that any of the applications that are built with this framework can inherit the benefit. Accessible widgets and controls, where there is not a widget or control, an accessible template, and where there's not even a template, accessibility guidelines and education. And of course, there's a lot of the education out there, which is great. So what did we do? The first thing, what I did was what I would say is a heuristic evaluation. So I would love to have a number 5 on this slide deck, and that is the aspirational target, which is actual engagement with special needs users and involving them integrally in the process. Now, this was something that we did on a faster time schedule, and we didn't have time to go to that level. But that's something that I would offer out to everybody, that's certainly the ultimate objective. But the first thing that I did was run a code checker. There are lots of code checkers available, and that link there that you can read and go to the W3C, there's a comprehensive list of code checkers there. Now, these are sort of, I would say, semi-automatable. You can run them against your code base, and they will tell you where there may be problems, even down to the code line number. The link that says that is under code checkers is just my pulling out of my top favorite 8, and that was built over a number of years of work. The second thing is navigating through the user interface with a keyboard only. And just unplug your mouse. So if you have a mobility impaired person who cannot use the mouse, can they access and do the tasks? So the first part of this is certainly defining your task set. What are the representative tasks? You know, examining the software, knowing how you would do this as a typical end user, but navigating through the task set without a mouse. So is keyboard entry enabled? The third thing was changing to looking at low vision. So change to a high contrast setting. Can you do all the tasks and see all the information that you need to see? Change to a low DPI, large font setting. At least 200x. You can try 400x, which is the next aspirational target. Try screen magnifiers. How does that work on your software? The fourth thing was navigating through the user interface with a screen reader. So could you turn off the monitor and actually get enough information from screen reading that you could make the same choices that you would make as a visual user in using the software? So that's the process we went through. We evaluated on 3 PCs, 2 PCs with Windows, a Vista machine and XP2, this is last fall, and 1 Mac with Apple OS X, the Lion system. 2 browsers. On Windows, it was Firefox 5 and Internet Explorer 8, and on the Mac, it was Firefox 5 and Safari. 2 screen readers on Windows, JAWS and NVDA. NVDA is an open source, free screen reader that you can download. JAWS 12, JAWS is a screen reader from Freedom Scientific, and it has quite a large market share. We looked at 2 DPIs, native and 200%. That's in place of changing resolutions, and 2 contrast settings. With the Apple, we looked at the screen reader, 1 screen reader, VoiceOver, which comes with the Mac, and 2 screen resolutions and 2 contrast settings. These were this is a list of the top 10 types of mistakes that we found. Some of them really easy to fix, and others that required some amount of new invention. And actually, here's where the partnership starts with the developer. Folks that are actually really well versed and skilled with code production and code creation, along with people who are really skilled with design and user experience and the objective that we're looking for there. I'm going to talk, in the interest of time, just about 3 of these things. If we have any time, I'll get into maybe an example from number 10 as well. but those are in the appendix, which you'll be able to look at by yourselves too later. So if you look here, this is just an example wireframe. You can imagine that when you first come into this page, I'm going to talk about the need for a skip to main content link. If you're a screen reading user and you are first loading this page and the screen reader is making you wait, so you're hearing tab 1 name, tab 2 name, tab 3 name, then you're hearing the breadcrumbs, and then you're hearing the navigation group, and then each of the navigation items, and then you come to the page title, and then you get the categories. If you're a frequent user of this page, that's a pretty slow process. So can you imagine coming into this page and having to wait or go through that? The skip to main content link is hidden. It's invisible. You don't see it in the UI. It's not needed by a visual user, but it's placed at in the beginning of the page code structure so that a non-sighted user, the screen reader, reads it and they can hit that right away. So they get right into the page, and there they have their categories and what not to do. So that's something that's very easy to do. It's something people forget to do, but it's advised. We're also going to look at, in this page, the opening a new browser tab not announced to the user. So for example, assuming, this is not like the design we would want to have happen, but assuming tab 2 name actually opened a new browser tab, and if that is not pre-announced to the end user, so they're hearing tab 2 name opens new browser tab, people who are using screen readers know very well how to handle navigating back and forth across browser tabs, but if they don't even know that they've been put into a new browser tab, and they now want to get back to tab 1 name, or to the information that was on tab 1. They don't know that they're in a new browser tab. It could be very disorienting. So anything that is going to open a new browser tab, we recommend that in the title tag that you give to that link or that action button or whatever else, you just say opens new browser tab. It just pre-announces for the end user. It's nothing that's shown visually. Won't interfere with your visual users. Won't clutter the screen. The third thing is the confusing focus order. With ARIA now, you can have control over focus order. You have the ability to actually make anything that is shown in HTML a focused item. So in this case, typically the tab order, if you're not managing it, is based on the order of the code, so how things are appearing in the document object model. So assuming that here, the tabs were first, hopefully, but that might not be the case. So it might be that you come in here and it actually reads the breadcrumb before it gives you the tab names, or it reads the navigation group. So you want to really be careful and make sure that you're looking at the tab order that your page is inheriting, and that you are actually explicitly controlling for it where it doesn't make sense. The other thing about tab order is, for example, these are two different, I'm using tabs in two different ways, but here you've got 3 tabs in this user interface, tab 1, tab 2, tab 3. That should be one keyboard tab stop. And then a user uses arrow keys and other things to go forward through the whole tab group if they want. The navigation group should be one tab stop. And then the user uses up and down arrow keys and other ways to go and navigate through that, so that you can just quickly go from the tab group to the nav group to the page, instead of everything is in the tab order. There's a way to do that. It's actually shown in the appendix. There are one thing, so I think we'll take a look just at tables. I'll just show you one example. So this looks like a single table. So for a visual user, it's interpretable. It looks like a single table. It's got column headings, and then it's got rows that are sortable. But if this table was produced by a widget that actually has implemented it for other good reasons I'll talk about in a moment as 2 separate tables, table number 1 is just 1 row, and that's the column headings. Table number 2 are all the data rows, and it's done in 2 tables so that the data rows can be sortable easily without getting the column heading row, intermixed in that sort order. That can be very confusing for a non-sighted user. You're just getting column headings, table 1, and then you go to table 2, and it's reading these things, A14, star, 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 2 dot star. Friend, you don't know where it is. You don't know where you are in the column heading structure. There is a way, if you have to live with a widget like that, and I mean, there were good reasons for this aspect, there's a way with ARIA that you can get around that. So it still is the same code. It still works for the visual user, but now it also works because you've added semantics into the code so that the semantics, the relationship between those two tables is understandable to a screen reader. They actually can see it as one table. ARIA provides the semantics where you can kind of bucket those two tables together, and you actually define the roles, like table head role, column header is count number, and you've got table roles. So it's the same table. It still works for the visual users. You can still sort it, but now it's also accessible with ARIA. So that's just one example. Okay, so just to conclude, this is a deep area. It requires a lot of study. It's pretty deep to get to understand the keystrokes that a screen reader adds. I mean, you've got keystrokes that should be by default for any user, even running without a screen reader. But screen readers also come with their own additional benefit keystrokes, shortcut keys. So it takes study to get familiar with those, and so that you can actually run a screen reader if you're not typically a screen reading user. I actually worked with two other folks at University of Washington. There's a lot of focus on accessibility at UW, and these two people were able to go through the UI as well and kind of corroborate or provide additional diagnostic or understanding about some of the things that I had found. So that worked out well. Again, there are tools and resources to help. This is just the final slide. There's a lot of stuff from the World Wide Web Consortium. University of Washington's page is here. The Paciello Group's page is here. Koali Rice's page, Microsoft, Apple, IBM, jQuery. We used a lot of the jQuery widgets and there's a lot of work across the community with the jQuery team to make them accessible. The Dojo Toolkit team, I know IBM works a lot with them and makes their widgets accessible and so forth. So there's some resources here for you. But in essence, I think we're just going to wait for the Q&A. So thank you.
All right. Thank you, Candace.